Good evening, everybody. I'm Tim K3LR. I'm here in my shack in Western Pennsylvania, and I'm going to share my screen. So I'm on the western side of Pennsylvania, near Pittsburgh, Pennsylvania, and this is me when I was 13 years old. I had just passed my general license exam, and I've been licensed since I was 12. And K3LR is 65 miles northwest of Pittsburgh, right on the border. If you're ever traveling on I-80, you may see the 14 towers from the interstate. You can see a lot of information about this station on my website, which is k3lr.com. There's lots of photos and drone videos, etc. And I encourage you to go there afterwards. So on the south side of Interstate 80 and right against the Ohio border. And one of the things that makes this QTH really work is the very fast drop off towards Europe and Japan. Over 75% of the contest QSOs that we make are with Europe and Japan. And so those are very important areas. There's 250 feet of drop off very quickly down to a riverbed, and that helps improve the average height of the antennas here. Taking a look overhead at the northern end of the property, there is a 160-meter rotatable vertical array, also two four squares for 80 meters, and then a big tower for 40 meters. In the middle of the property is the tower that we use for running stations calling CQ on 15 meters and 10 meters, and then the tall 20-meter tower as well. So the tallest tower here is the 40-meter tower. There are three full-size 4-element Yagis on this tower, so you can see these Yagis. One is at the top of the tower, in about the middle of the tower, and then down here. Those are three 40-meter Yagis. The reflector is 75 feet long on these antennas. They weigh 410 pounds. Very large antennas, but they work very, very well. There's also antennas for 10 meters and 20 meters on this particular tower. And taking a look at what the tower looks like from my neighbor's house, so you can see that it's very important to have good relations with the neighbors, and you can get an idea of just how large the tower is and how large the 40-meter Yagis are. Here are some 10-meter Yagis down the side of the tower. All these towers are Pyrod towers. They're solid steel legs, very strong. In the middle of this tower is a horizontal wall or flag antenna. That's a receiving antenna that we use for 160 meters. And taking a look up at the tower, you can see it's very busy with these ring rotators that allow us to turn antennas that are side mounted around the tower itself. Taking a look at the 20-meter tower, there is a 80-meter dipole on top of the mast at 245 feet, and then 4 of these 6-element Yagis. These are for 20 meters. And so there's 24 elements on 20. Taking a look down the side of the tower, another one of the 20-meter Yagis, another 20-meter Yagi. And also in the middle of the tower are two 2-element Moxons for 40 meters. And again, everything is on a ring rotator. The guy wires are all Philly strands, so they're all non-conductive. And again, the Pyrod tower. Taking a look up the 20-meter tower, you can see it is also busy. And on 10 meters, there are 4 8-element Yagis for calling CQ, and they start at 135 feet and go all the way down to 33 feet. On 15 meters, these are 7-element Yagis, and there are 4 of them. And so it's 160 over 120, over 80, over 40. And then on top of the mast is a 10-element 6-meter Yagi that is used primarily for finding noise, although we do work some of the summertime sporadic E-openings. Back in 2018, we replaced the 20-meter tower with a new tower, and so got the opportunity to shoot some photos with the crane involved here. The new tower, of course, is brightly painted. The old tower is the one that has the worn paint on it, using a 100-ton crane and then lifting the sections into place, placing the Philly strand guy wires on the pie rod tower along with the ring rotators to accommodate the side-mounted antennas. This is taking a look at the top of the 20-meter tower. You can see the DX Engineering 3-inch thrust bearing for the mast, as well as you can see the very strong tower, solid steel legs, and can support lots of wind load. This is 2 out of the 4 20-meter Yagis being prepared to be installed. Notice that the reflectors are down here at the bottom, and then the last director is up here at the top. So the driven element is here, and the first director is very close to the driven element. This is known as an optimized wideband array, and it exhibits a feed point impedance of 50 ohms, and it stays at 50 ohms across the entire band. So the SWR on 20 meters never gets above 1.25 to 1. So these are very, very nice Yagis, great pattern, and built with DX Engineering hardware. This is the top 20-meter Yagi going into position with help from the 100-ton crane. And antennas going up the side of the tower, and then in position at the top of the tower. And you can see here's the mast that goes up to the 80-meter dipole, and the steps that are on the mast that allow us to go up and service the 80-meter dipole if we need to. And then using FaceTime, we were able to get the VSWR right from the top of the tower, from the tower crew, to make sure everything was okay before tightening everything down. This is the driven element of the 40-meter Yagi, one of the 3 40-meter Yagis. Notice the fiberglass insulator in the split driven element. This side has the shield of the coax. This side has the center conductor of the coax, and that's right on red. So if you're standing on the tower, all of the feed points are on the right-hand side of the driven element. And that's very important from a phasing standpoint, using very thick Garolite insulating plates and DX Engineering hardware. So you can see, again, this is the optimized wideband array, the first director very close to the driven element. And then you can see Interstate 80 here in the background. So these are trucks on Interstate 80. The full 40-meter Yagi, notice the elements, they sag, but that's because they're quite long. They are designed to sag, and this antenna can withstand over 100 miles an hour of wind with ice. And working on the 40-meter tower with the 100-ton crane, and putting the top 40-meter antenna into place here. And this is a geochron. It shows where the areas are sunlit and sunset. It also shows the gray line in real time. And we have 4 geochrons here in the shack to keep track of the sun. We use large heliacs to keep losses low, 1 5/8 for 10 meters and 15 meters, and 7/8 for everything else. I mentioned the 160-meter transmit array, which is it starts out as a quarter wave tower, so that's 120 feet tall, and then it has 4 parasitic wires that can be used as directors or reflectors, or they float. In the case of this example, the right-hand yellow element is grounded, so that becomes a director. The left-hand yellow element goes through a small inductor and becomes a reflector. Then these 2 side elements that are blue, in this case, that are floating, so they're out of the picture. So by using relays at the bottom of these wires, these T wires, we can make this into a 3-element vertical beam. So you have a director, the driven element is always the tower, and then a reflector. This is the bottom relay box at the bottom of the T-wire, including 120 radials that are 130 feet long each. This is the base of the feed point of the 160-meter transmit array. It is so far away from the shack that we had to use 1 5/8" to keep the feed line losses low. 300 radials are underneath this tower, and this works very well on 160. For 80 meters, we have 8 towers that are dedicated to 2 4-squares. The 4-square is a directional antenna that comprises 4 towers working together to optimize the gain and front to back. This is the radial system underneath one of those 8 towers, showing the copper straps. Another shot of the silver soldered radial system, and the center 4 towers of the 4 squares. And again, lots of attention to making sure the radial system and the grounding system is done correctly. A few years ago, we decided to put aluminum towers in place of the steel towers. So these aluminum towers have all been welded together, so there are no real mechanical joints, and that's to keep the losses as low as possible. And then once we put the towers in place, we tune the exact resonant frequency of each individual tower with this top 2-inch stinger. And here you can see putting the towers in place. Aluminum tower from Universal Tower up in Michigan. And you can see here's the tower with the ground screen and the custom DX Engineering insulators underneath. And this is one of the 4 squares. So 1, 2, 3, 4 towers. 160-meter tower is in the background. And tuning the stingers requires the use of antenna analyzers and spectrum analyzers, but everything has been tuned and everything stays in phase. These are the Comtech Systems boxes that actually combine each of the 4 verticals. We also have 4 squares on 20 meters. Here's the 4 aluminum verticals on 20 meters. These are a 1/4 wavelength long, so they're about 16 feet. And here's for 15 meters, a little shorter. And then for receiving on 80 and 160 meters, we use active verticals that are 23 foot tall. A little difficult to see here with the trees, but there are 8 of these 23-foot verticals. In the center, you can see here's the 23-foot vertical, another 23-foot vertical. In the center is the combining box. In here, all the verticals are terminated, and then using toroids and capacitors, we can actually create directive patterns, and using chokes to make sure that the outside feed lines stay cold. Here I am with my friend W3YQ. We're tuning up the array and making sure that it is set for best performance. Lots of RG6 cables, 75 ohm cables is what it takes to run this. And everything is in place. And here's the, at the base of each one of those 23-foot receiving verticals is a small box that has a buffer amplifier, plus chokes, one for the signal and one for power lines. And also here are the buffer amplifiers that it takes to do the 4 square and the 8 circle here at K3LR. This is the inside the choke box. 26 turns of small 75 ohm coax is used, and that creates a very high common mode impedance. This is the house at K3LR. It was built in 1865. Everything has been added. You know, you think about that, 1865, there was no electricity, no natural gas, etc. But everything is here now, including a world-class amateur radio station. We have our own 50 kilowatt transformer from the power company. If that fails, I have a 50 kilowatt Kohler generator that comes online 7 seconds after a power outage. Here's the shack at K3LR showing 11 operating positions. Here are 3 of the positions. This is the 160 meters position here, and then 2 positions on 80 meters. 1 position on 80 calls CQ the entire contest. The other searches for stations that are calling CQ. The feed lines come in underground, and then they come down into the shack, which is at basement level. And another shot of feed lines coming in from the northeast cable entrance. We have 13 8-foot ground rods in the floor. So we have a very good, very short connection to earth ground. Operators having fun at K3LR in a CW contest. There's K1DG and N0AX. And then in a phone contest, you can see the boom microphones from Heil, and they are mounted on the Bose QC15 headsets. And again, the 2 operators on 15 meters, the operator on the left is the operator that calls CQ, and the operator on the right is looking for stations that are calling CQ. This is the second station on 10 meters, has its own radio and rotors, antenna switches, amplifier, etc. And we have custom designed antenna switching. The relays are out on the tower to do the switching. But in this case, the 40-meter stack that we talked about, which has got 3 full-size antennas, here they are. They're all being fed right now. The operator has chosen to put 1/3 of the power in each one of these antennas. Here's the switching box for 15 meters, and the 2 operators on 15 CW, N6 TV, and N6 AM. They have to work together because only one transmitter can be on the air at a time on 15 or on any band. So they have to coordinate between each other. 15-meter run, they've decided to feed the bottom 3 antennas known as bot 3. And so the 160-footer is shut off. And then they have a heads-up display here that shows the three bottom antennas being fed. I like the Drake W4 watt meter, and we put some new SO239s. After 60 years, they're still going strong. These are the rotator boxes for the 3-high array on 40 meters, and size does matter. It is an exceptional 40-meter antenna. There are single band amplifiers here. This is my design, single AD877, and the amplifiers are designed to run 1,500 watts all day and all night and not give us any trouble. Each one of the amplifiers has its own 4,000-volt power supply. Here's the 20-meter run position with its amplifier, rotator boxes, computer, etc. This is the 20 run on the right and 20 mult on the left. This is the station that calls stations that are calling CQ. This station calls CQ. So 2 independent stations, but the operators have to work together. 2 stations on 10 meters here, the ICOM IC7851s, and 160 meters. There's only 1 station on 160. And for the CW contest, I operate K3LR on 160. And then on the phone contest, John, N2NC, is the phone operator. We use the DX Engineering noise canceling controller to phase antennas together on 160 meters, the Bose QC15 headsets, and the ICOM IC7851 is our radio of choice. We use that at every position, and they are outstanding radios. Here's Al, N5UM from Oklahoma City, who operates 75 meters with us, and Al taking a little bit of a snooze break at 4 a.m. Also notice the Intel NUCs. These are the computers that we're using now, very small, no RFI noise, run on 12 volts. They're really, really good Windows machines with solid state hard drive, sound card, etc. To share the 2 the dual four square on 80 meters. We have the 80 meter XL twin turbo +2 switch designed by W8WWV that allows us to switch between the run and the malt stations. We have high power harmonic filters to beat down the harmonics on 80 meter on all bands. We have these harmonic filters, very important. When operators are not operating, they are resting at the DX barn, which is a custom design barn that allows, it has a full kitchen, has restroom facilities, showers, and sleeping for 8 upstairs. Operators having fun this on 20 meters, Andy N2NT and John VE3EJ. We have had over 175 different operators operate here at K3LR. Sometimes the operators have to take a break. This is about 4 o'clock in the morning on 20 meters. We use the DX Engineering foot switches on SSB. This is our lockout box that goes between the run station and the multiplier station to ensure that only one station is on the air at a time. This little aluminum box tells the mult operator if the run station is transmitting, which has the red light. That means he's going to be locked out. So he wants to wait till that light goes out. The multiplier stations also have control of their receive four squares, and operators having a good time. Both these guys were here recently to operate contests at K3LR. Dave KM3T hails from New Hampshire. John K1AR also from New Hampshire. Otis NP4G from Puerto Rico, and George N3GJ from Pittsburgh. 10-meter operators, and Otis is fluent in Spanish, so that's very helpful. And these guys did not get much rest this past weekend, as 10 meters was very good. Justin G4TSH from London, England, likes to come over for the CQ Worldwide contests on CW. And here you can see all the positions. Here's the 2 positions for 40 meters, 80 meters, 160, 2 on 15, 2 on 10, and then the 2 on 20. I am very pro youth being allowed to operate this station. This is Violetta, KM4ATT, and Bryant, KG5HVO, in the 2019 WPX phone contest, operating the 20-meter station. Here's K6JO and VE7DZO from British Columbia, operating the 40-meter station. These 6 youth operators are filling out thank you cards because they raised over $5,000 in a GoFundMe to cover the expenses to come to K3LR. These 6 operators hoped to have completed 3,800 contacts in the multi-2 category in the contest. At the end of 48 hours, these 6 youth operators who had never operated together before had made over 6,000 contacts, and they made all the contacts. The parents and the old timers did not make any QSOs. That was good enough for number 1 in the USA, number 1 in North America, and number 4 in the world. Here's, I also opened the shack for the 13 colonies. And so in July, we are the Pennsylvania station, Kilo 2 Mike, again, opening to young youth operators. Michael here, W3MLJ, who's now 18 years old, he just went on his first contest expedition to the Virgin Islands. They were November Papa 2 radio last weekend. I get visitors from all over the world that stop at K3LR. Here's one from Finland. And here's Hal, W8HC, who was just out in Timoto at H40 Whiskey Alpha. And also, I'm sorry, was down in Juan Fernandez, Charlie Bravo 0 Zulu Alpha. And here's Riley, K4ZDH, who formerly worked at the FCC. We keep track of high QSO counts and multiplier counts. Analytics is part of what we do to try and make sure that we have the best possible scores going forward. And we also participate in the reverse beacon network by having the CW skimmers. This used to be the computer rack. This is the new computer rack, which is made out of Nook computers. And so has significantly shrunk using the Nook computers. These are the 6 software-defined receivers. The Perseus, I hand carried these from Italy, and they are outstanding receivers for copying CW for the CW skimmer software that gives it to the reverse beacon network. Lots of ferrite here at K3LR, keep the noise down. And using analog power supplies, no switching power supplies. During a contest weekend, there are not even an iPhone charger that is allowed. This is a switching power supply free zone, and that keeps the noise floor very low here. We make coffee 1 cup at a time. Also, it takes a lot of food to fill or to feed a contest team over the course of a weekend. This is the snack table, and our chef Sal from Houston, Texas, who was here this weekend, and he likes to smoke filet and ribs, etc. We eat very well, but Army travels on his stomach, so Sal takes care of the kitchen, WM2H. And breakfast is made to order, and then the operators operate and eat at the same time. WindTest is our logging software since 2006, and keeps track of all our QSOs and multipliers. And here's a score screen from a few years ago when we had over 3,000 contacts for the weekend on 15 and on 10 meters. So, and conditions are outstanding in 2024. I'm a voracious QSLer, sending QSO cards to every QSO that we make. And also I like t-shirts. This is Team K3LR and CW. After the contest is over, we go and talk to other multi-op stations on the real 3830 after the contest, talking to NR4M, maybe it's K1LZ, maybe it's KC1XX and W3LPL. We do operate RTTY contests sometimes, and sometimes we win a plaque. ILTHRS, I love this ham radio stuff. And so this was a crew back in 2017. Sal brought his girlfriend, Olivia, to help out in the kitchen. So that's why you see the YL in the photo, but you can see happy faces here. Good score in the contest. CQ Worldwide 2014 with G4TSH from England, N6AN from Los Angeles, California, and other N6MJ from Los Angeles, KL9A from Montana. CW crew in 2018, this is what it takes. It takes 12 to 14 operators to man this station for 48 hours over the course of a weekend. And the reason we do this, we're best friends. And we have a great time doing this. Many of these guys I've known for over 50 years, and we're still having a lot of fun doing it. I'm very proud of the fact that we opened the K3LR station to clubs and schools. This is the University of Pittsburgh Pitt Panther Amateur Radio Club, W3YI, along with their advisor. They recently spent the day here at K3LR. We talked about amateur radio. We talked about life after amateur radio, and after college, and how amateur radio can be a part of their life going forward. But we have somewhere between 15 and 20 tours here every year. And that is my presentation, and I will stand by for any questions you might have.